everyone, and welcome back to Introduction to Finance. Today I'm going to be showing a bond price example using the time value of money equations. So the example we're going to be solving today is kind of like the first step in solving one of these bond problems, which is where we just have annual coupons. Then later, oftentimes in like Principles of Finance or Introduction to Finance courses, the problems will become more difficult. So you'll end up with something like semi-annual coupons, or you'll get into the actual bond market where there's not exactly 6 months or 1 year until the next coupon payment, where you have to calculate clean and dirty prices. Here, we're just going to be doing the baseline, which is annual coupons for a bond. So let's look at the different inputs that I have. So first up, I have face value of 1,000. I have 3 years to maturity remaining, a coupon rate of 5%, and a yield to maturity of 7%. And what I'm going to be trying to solve for today is the bond price using different time value of money equations. So first I'm going to solve it using the formula, then I'm going to solve it on a financial calculator, and this is the Texas Instruments one. I'll have this one linked down below. You don't have to have the professional, you can have the regular one as well. Either one of them will work. So let's start with our timeline. So on the timeline, I have 3 years to maturity remaining. So that's what I started with 3 years here. Now the face value is the easiest one to fill in on the timeline. The face value we get back at the end of the bond or when the bond matures. So I'm going to add $1,000 to the end of my timeline. Next up, I need to figure out what the interest payments are going to be that I'm going to receive for this bond. And the interest on a bond is called a coupon. So we know what the coupon rate is. The coupon rate is 5%. So from this 5%, we can figure out what each one of these cash flows is going to be. So the equation for coupon rate I just wrote out here. So coupon rate equals the annual coupon divided by the face value. So I know the coupon rate and I know the face value, so I can rearrange to solve for this annual coupon. To get the annual coupon, I'm going to multiply the coupon rate by the face value. So I end up with an annual coupon of $50. Now, these are annual coupons, so they're going to happen once each year at the end of each year. So I'm going to have 50, 50, 50. Now I've identified all of the cash flows on my timeline. So next up, I want to figure out what the bond value is, or the bond price, at time 0. To do this, I have to discount back each one of these cash flows. And there's different sets of cash flows that we can group together. So first let's look at the coupons here. So these coupons are an equal amount over a fixed amount of time, and they're all equally spaced. Because we meet those 3 requirements, we can group these 3 cash flows together as an annuity, and we're bringing them backwards on our timeline, so it's going to be the present value of an annuity. Then next up, we have the $1,000 here at the end. The $1,000 is just a single cash flow. It only happens one time on our timeline. And we want to bring this one back to time 0. So to bring that back to time 0, we're going to use the present value of a single cash flow. So if I write out each one of these equations, so first up I have the present value of an annuity, then I have the present value of a single cash flow. Now I can fill them in with the different inputs I have. So let's start with the present value of the annuity. First up, a lot of times this will be labeled as payment or cash flow. All that's referring to here is whatever the coupon is. So our coupon in this case is $50. And now we have to do this whole portion in brackets. So let's start with the T. The T is the easiest one to do. So T in this case is going to be the total number of coupons or the total number of years. So here we have 3 years, 3 coupons. So we're going to have -3 as our exponent. Next up, we need an R value. So the R value is what we want to discount back each one of these cash flows at. We don't want to discount each one of the cash flows back at the coupon rate. The coupon rate just tells us what each cash flow is going to be. The rate that we want to discount back each one at is going to be the yield to maturity. So this 7%, that is our discount rate. That's my first term. Then to that, I'm going to add on the present value of a single cash flow. So my face value is 1,000. I'm discounting it back at, again, 7%. And I'm discounting it back 3 time periods. So now those are going to be my 2 terms, and I can go through and solve each one. I'm going to end up with a final answer of $947.51. Now another alternative to solving this out by hand using the equations is we can use a calculator function for time value of money. So in this video, I'm going to be showing it to you on a financial calculator. I do have a separate video showing a graphing calculator, so if you're looking for that video, I'll have a link down below. So first, let me turn this one on. The inputs that we're going to be using are these ones right across this row. So we have N, I over Y, PV, PMT, and FV. So what these stand for is N is essentially like the number of periods, I over Y is our rate, PV is present value, PMT is payment, FV is future value. So let's label what each one of these cash flows are going to be over here first before we type them into our calculator. So N, that's essentially the same as the T in our equation. So we want that to be the number of years or the number of cash flows. So in this case, we have 3 cash flows. So this is going to be 3. I over Y, that's going to be our R in our equation, or our rate. So here, we're going to type this in as 7. And that's an important thing to emphasize here. We have to type in this rate as a percentage into the calculator. So we're going to type it in as 7, not 0.07. Next up is PV. This is what we're solving for. So PV, we're solving for that price or that present value right now, whatever the value is at the beginning of the timeline. Next up, we have payment. So we want this to be our coupon. So our coupon here is 50. Then lastly, FV stands for future value, also matches face value. So here we're going to have the face value of 1,000. So now that we've figured out what the inputs are, let's type those into our calculator. Before I start, I'm going to clear out my time value of money function. So I'm going to do second, then FV, and that clears the time value of money, or it does the function that's right above whatever the button is. I also always like to clear my work, so I'm going to do second, and then hit the clear button down here at the bottom. Now I've cleared out my calculator. So first, you type in the number, then you hit the time value of money button. So I have my N is 3, so I'm going to do 3, and then I'm going to hit N. Then you just move right on to the next one. So next up I have 7, that is my I over Y. This one I'm going to skip for now. Then I have 50, that's my payment. Then lastly, I have 1,000, that's my FV. Now in order to solve it, I'm going to quit out of this menu. So I'm going to do second, compute. Now I need to solve for what the answer actually is. To do that, I'm just going to press the compute button. Now it's solved for the missing variable. So now I can click on PV. And it tells me the present value is negative 945.51. Oops, sorry, negative 947.51. So that perfectly matches what we had above, right? We got the same value. You'll just notice that there is a negative sign here. So whenever you're doing these problems on financial calculators, graphing calculators, Excel, anything like that, everything thinks of it as cash inflows and cash outflows. So the reason this comes out as a negative number is because we're essentially buying the bond today for $947.51. So that's a cash outflow from us. Then we end up receiving the coupon payment each period, and we receive the face value at the end. So both of those are positive values because those are both cash inflows. So I hope you found this video helpful, showing how to use the time value of money functions to solve an annual coupon bond problem. In my next video, I'm going to be showing this exact same problem, but now we're going to switch it to semi-annual coupons and determine what has to change both in the equation and in our calculator inputs.